Section 10.1 is on exploring conic sections. A conic section is the curve that you get when you intersect a plane and a double cone. Let's take a look at these diagrams here. So here's our double cone. They're kind of nose to nose right here. And if we take a plane and it intersects either one of the cones and it's parallel to the base, then the resulting shape that we get, that intersection, is a circle. If we take the plane and we slant it and intersect the cone and actually go through its base, this shape that we get here is a parabola. If we take the plane and again slant it, but we don't go through the base, the resulting shape we get is an ellipse, or kind of an oval. And then if that plane is perpendicular to the base, going straight up and down like this, we get a shape called a hyperbola, which actually has two branches, this one up here and this one down here. Let's take a look and explore a couple of these conic sections. So my example says we need to graph x squared plus y squared equals 16. We need to identify the conic section, state its center, intercepts, lines of symmetry, domain, and range. So first thing I want to do is probably the easiest given this equation is finding the x and y intercepts. So I already started that a little bit down here. So what that means is I want to let x equal 0 and y equal 0 and solve for the other variable. So when x equals 0, I have y squared equals 16, and then y is equal to positive or negative 4. So that's going to give me y-intercepts of 0 and plus or minus 4. If I let y equal 0, then I get x squared equals 16, and x is equal to a positive or negative 4, and that's going to give me x-intercepts of positive or negative 4, comma 0. Let's go ahead and put those in our solution, up here. So my x-intercepts are going to be positive and negative 4. Y-intercepts are also positive and negative 4. And I'm going to go ahead and graph those points here. So it kind of looks like I'm going to have a circle, but I'm not positive. I'd like to fill in some additional points, and I'm going to use my calculator to do that. So in order to graph in the TI calculator, it only graphs functions, so we actually have to solve this for y. So let's solve our equation for y, subtracting x squared on both sides. Gives me y squared equals 16 minus x squared, and then taking the square root of both sides is going to give me a positive or negative 16 minus x squared. And when I go to my calculator, I need to put both parts of those into the calculator. Here, I did it here. So into y1, I'm going to put the square root of 16 minus x squared, and into y2, I'm going to put negative square root of 16 minus x squared. And taking a look at the graph of that, it is indeed a circle. And you'll notice it actually had to do the two parts. This is the positive square root part. The red is the negative square root part. And I have to do that on this calculator because it will only graph functions, and a circle is not a function. And next thing I want to do is go to the table and get a few additional points. I already know about 0 being when x is 0, y is positive or negative 4, and when x is positive or negative 4, y is 0. But also if x is positive or negative 2, I get a positive or negative approximately 3.5. If x is a positive or negative 3.5, I get that y is approximately equal to positive or negative 2. So I'm going to go ahead and add those. So positive or negative 2 and positive or negative 3.5. And positive or negative 3.5, and positive or negative 2. And then graphing those points, I'll get what looks like the rest of the circle. So I have that, and that. Let's see, 2, 3.5, 3.5, and then 3.52. It's not going to be exact, but this is close enough. And indeed, I do get my circle. Okay, so looking at the graph of this, I can tell that the center is 0, 0. My lines of symmetry are going to be actually all lines that go through the center. Okay, and now for my domain and range. In other words, for my domain, what can x be? Well, you'll notice that x can be any value between negative 4 and positive 4. So I'm going to write it like this. Negative 4 is less than or equal to x, which is less than or equal to 4. And same thing for my range. Notice my biggest y value is a positive 4, my smallest y value is a negative 4. So negative 4 is less than or equal to y, which is less than or equal to 4. And I forgot to name this. This one is actually a circle. Two more examples here, which I've actually, in the interest of time, I've already gone ahead and worked out here. This example says, oops, let me move that up a little bit. Graph 27x squared plus 3y squared equals 27. Identify the conic, state its center, intercepts, lines of symmetry, domain, and range. When I did this one, I went ahead and I started again with the x and y intercepts, which I've done down here. So I let x equal 0. Let the page load here. So when I let x equal 0 and I solve for y, I get that y is positive or negative 3. That's going to give me my y-intercepts. When I let y equal 0 and solve for x, I get that x equals positive or negative 1. And I graphed those on there on the graph. Then I decided to solve the equation for y so I could put this into my calculator and see what it looked like. So subtracting 27x squared on both sides, dividing by 3, and notice that I can actually factor a 9 out of here and then bring that outside the square root so that I have y equals plus or minus 3 times the square root of 1 minus x squared. Putting that into my calculator, I could confirm that it was that oval shaped, kind of more longer than it is wide. And then using my table, I got a couple additional points. So those are the points that I graphed here. Okay. My x-intercepts of positive and negative 1, my y-intercepts of positive and negative 3, and then my additional points here. In this case, you can see that my center is going to be 0, 0 again. And in fact, in all of the examples we're looking at today, the center is 0, 0. My lines of symmetry in this case are not going to be every line through the center, but only the x-axis and the y-axis. And my domain are any x values between and including negative 1 and positive 1. And my range are the y values up to and including positive 3 and negative 3. And the shape of this one is an ellipse. And our last example, I've also already worked this one out. Okay, this one says graph y squared minus x squared equals 36. Identify the conic section and again state its center, intercepts, lines of symmetry, and domain and range. So again, I went and I did the x and y intercepts. Did that down here. I let x equal 0. And when I solve for y, I got that y is positive or negative 6. Now curious, when I let y equal 0 and solved for x, I got that x squared equals a negative 36. That's not a real number, so there are no x-intercepts. Went to my calculator, solved for y, and came up with y equals plus or minus the square root of 36 plus x squared. And I put that into my calculator and got these additional points. And then when I graphed them here, okay, I get this funny looking shape right here with the two branches, and you should recognize that as a hyperbola. And again, I can see that this one is centered at the origin. It has no x-intercepts, as you can tell from the two branches of this graph. It's never going to cross the x-axis. And my y-intercepts are positive and negative 6. This also has lines of symmetry that are the x-axis, it'll flip over itself, and the y-axis. My domain in this case can be all real numbers. Notice that x can be anything. It continues to go up this way and out, both to the right and to the left. My range, notice this is a compound inequality. Y can be any value that's less than or equal to negative 6, and I need to use the word or in there because I want both parts. Y can be any value greater than or equal to a positive 6. So in this section, we took a look at some conic sections, 3 of the 4 conic sections, a circle, an ellipse, and a hyperbola. And just so that it's a little easier for you to recognize these, I want you to notice that the circle has an x squared and a y squared with no coefficients. And it has addition. The equation of an ellipse also has an x squared and a y squared, but it can have coefficients. In fact, at least one of them has to have a coefficient, and this also has addition between the two terms, the two squared terms. And for a hyperbola, in our case, Okay, it did have an x squared and a y squared. Our case didn't have coefficients, but it can have coefficients. And what makes the hyperbola different is that it has subtraction between the two squared terms. So, good luck with the examples here, and have fun identifying conic sections.